A stellar black hole with a record high mass has been detected in the Milky Way. Thanks to the Gaia Observatory, the European Southern Observatory's telescope and other ground-based instruments, scientists have tracked down a record-breaking black hole in our galaxy. Polish astronomers from the Astronomical Observatory of the University of Warsaw took part in the research. The vast majority of the dozens of known stellar black holes are found in binary star systems. These systems emit X-rays, which is related to the loss of material by the star as it is sucked out by the black hole. However, if the black hole does not have such a nearby star nearby, we do not observe any radiation. It is then difficult to find such a dormant black hole. However, scientists from the Gaia Space Observatory managed to do it. The third object of this type, a dormant black hole, has already been discovered, and it is a record-breaking one in the entire galaxy. Interestingly, the discovery was accidental and was made while validating data for the next Gaia mission catalogue. Due to the importance of the discovery and the fact that the publication of the catalogue is planned for 2025 at the earliest, it was decided to publish the results of analyses based on preliminary data earlier. The research results were published in Astronomy and Astrophysics. Scientists analyzed the behavior of an old, bright star in the constellation Aquila, 1,926 light-years away. Based on its orbital motion, it was determined that it is in a binary system with a dormant black hole with a very high mass, estimated to be 33 times greater than the mass of the Sun. It was called Gaia BH3. This result is a record among stellar black holes in the Milky Way. The previous record holder was a black hole in the X-ray binary system Cygnus X1, with a mass about 20 times that of the Sun. However, the typical mass of stellar black holes in our galaxy is about 10 solar masses, with a mass 30 times greater than that of the Sun. We observe results typical of measurements of the masses of very distant black holes observed by gravitational wave experiments. Gaia measurements constitute the first irrefutable evidence of the existence of such heavy black holes, explains Professor Łukasz Wyrokowski from the Astronomical Observatory of the University of Warsaw, who has been a member of the Gaia team since 2008 and belongs to the special group on black holes. Astronomers now face a difficult task, trying to explain the origins of black holes as large as Gaia BH3. According to mainstream theories, as massive stars evolve, they lose much of their material through strong stellar winds and the ejection of some material during supernova explosions. What is left of the star's core shrinks and becomes a black hole or a neutron star. The mass decides here. It is very difficult to explain a remnant large enough to produce a stellar black hole with a mass as much as 33 times that of the Sun. The star itself orbiting Gaia BH3 is also interesting. It orbits the black hole at a distance 16 times the Earth-Sun distance with a period of 11.6 years. This star is a giant, formed in the first 2 billion years after the Big Bang. Back then, The Milky Way was just forming. The star contains very few elements heavier than hydrogen and helium, so-called metals in astronomical terminology. And since stars in binary systems usually have the same composition, this suggests that the star from which the black hole was born was also low in metals. It is surprising that the chemical composition of the companion is similar to that found in old, metal-poor stars in the galaxy, explains Dr. Milena Ratichak from OAUW, a member of the Gaia Consortium. This is the first confirmation of the idea that the high-mass black holes observed in gravitational wave experiments were created by the collapse of primordial massive stars poor in heavy elements. Such objects may have evolved differently than the massive stars present in the Milky Way today. Gaia is a space observatory belonging to the European Space Agency, ESA. Its main task is to measure the distances to many stars in order to prepare a three-dimensional map of the Milky Way. At the same time, the collected data is used by scientists to conduct research on many other issues in astronomy, an example of which is the discovery described. To confirm the discovery, the researchers used data from ground-based observatories, the UVES spectrograph on the VLT telescope in Chile, European Southern Observatory, the Hermes spectrograph on the Mercator telescope on La Palma in Spain, managed by the University of Leuven in Belgium, in cooperation with the Observatory of the University of Geneva in Switzerland. The SOPHY spectrograph at the Haute-Provence Observatory in France, managed by OSU Institute Pythais. Water vapor discovered in Europa's thin atmosphere. Observations using the Hubble Space Telescope have revealed the persistent presence of water vapor on Jupiter's ice-covered moon Europa. Interestingly, the analysis showed that water vapor in the thin atmosphere occurs only on one side of the moon. Europa, one of Jupiter's 79 moons, is the fourth largest moon of Jupiter and the sixth largest moon in the Solar System. It is an icy ball larger than the dwarf planet Pluto but slightly smaller than Earth's moon. The surface of Europe is frosty, with an average temperature of -170 degrees Celsius. However, astronomers suspect that Europa hides a huge ocean under its icy crust, which may hold up to twice as much water as Earth's oceans. Thanks to the temperature coming from the interior of the Moon, the oceans may have conditions favorable to complex chemical reactions. Some researchers consider the possibility of microbial life there. Now a team of scientists has discovered evidence of persistent water vapor in Europa's thin atmosphere. Previous reports of water vapor on Europa involved ESA activity. Observations using the Hubble Space Telescope in 2013 and data from the Galileo spacecraft newly analyzed in 2018 confirmed that ESAs eject plumes of water vapor into space. A description of new observations regarding the constant presence of water vapor in Europa's thin atmosphere was published in Geophysical Research Letters. This discovery is the result of a new analysis of archival images taken by the Hubble Space Telescope between 1999 and 2015. Researchers using a technique developed by Lorenz Roth of the Royal Institute of Technology in Stockholm, which recently resulted in the discovery of water vapor in the atmosphere of Ganymede, another moon of Jupiter, found evidence of the permanent presence of water vapor on Europa. The time range of the analyzed images suggests the long-term presence of water vapor. Previously, it was believed that Europa's thin atmosphere consisted only of oxygen. But detailed analyses of archival data recorded using the STI's Space Telescope Imaging Spectrograph on the Hubble Space Telescope showed that water vapor hovers just above Europa's surface. However, it is not evenly distributed over the entire surface of the object, but only occurs on one half of the Moon, the one that faces away from the direction of the Moon's motion along its orbit. The reason for this asymmetry is not entirely clear. Observing water vapor on Ganymede and on the back side of Europa allows us to better understand the atmosphere of the icy moons, Roth said. However, the detection of stable water on Europa is slightly more surprising than on Ganymede, because the surface temperatures on Europa are lower than on Ganymede, he added. Scientists explain the presence of water vapor on the surface of Europa and on Ganymede as sublimation of water ice, i.e. the transition of ice directly from the solid state to water vapor, bypassing the liquid phase. Scientists will soon have the opportunity to learn more about Europa and other icy moons in the solar system. The Europa Clipper mission is scheduled to launch this year and will be used to conduct in-depth research on the icy moon. The spacecraft will carry 9 science instruments, including cameras and spectrometers to image the lunar surface in high resolution, a magnetometer to measure the strength and direction of the magnetic field, and an ice-penetrating radar to determine the thickness of the ice crust over the ocean. During its mission, the spacecraft will make 40 to 45 passes over Europa, examining the Moon's icy crust and subsurface ocean, providing data necessary to assess Europa's environment. But this is not the only mission heading to Europe. The European Space Agency's Jupiter Icy Moons Explorer, JUICE, launched in 2022 and undertakes to explore the atmosphere and magnetosphere of Jupiter and 3 of its moons, Europa, Callisto and Ganymede. The satellite will cover a distance of 600 million kilometers and will be in Jupiter's orbit in 2029. JUICE will conduct observations for at least 3 years.